Hello everyone, happy to see you here. Today we have really interesting equations, 3 to the power k minus 2 to the power k equal to 5. We need to solve this equation for k, so if you have your solution, your answer, you can also write it in the comments below and then we will check our answers. Okay, so there are a lot of ways how can we solve this question. The first one is geometrical way, but I'm going to show you the algebraic way how can we solve this question. First of all, instead of 3 to the power k, I want to write the next expression. I want to write square root of 3 to the power k and raised to the power 2. Basically it changes nothing because right here we can easily cancel this 2 with this square root sign. So basically this is the same 3 to the power k. And the same thing with 2 to the power k. So square root of 2 to the power k and raised to the power 2 equal to 5. So what we're gonna do next? Right now, let's instead of this square root sign, let's write it in a different way. So we can write it because everyone knows that square root sign is the power 1/2. So that's why we can write this one as 3 to the power k over 2 raised to the power 2 and minus 2 to the power k over 2 and raised to the power 2 and equal to 5. So basically it changed nothing because right here we can easily cancel these 2, so we have the same 3 to the power k. But right now let's look at this question from a different perspective. So 3 to the power k over 2, let's call for example as a, and this expression we can call as b. So basically what do we have? A square minus b square. So first of all, on the left side, let's write our substitution. So let 3 to the power k over 2, this is our a, and 2 to the power k over 2, this is our b. So basically right here we have a square minus b square. So a square minus b square equal to 5. So this is our difference of squares, and everyone knows this formula. This is a classic school formula. We can write this one as a minus b times a plus b. Okay, we can write it as a plus b times a minus b equal to 5. Right now, a few thoughts about this 5, because if we look closely on the left side, we have a product of two parentheses. So in other words, we have product of two values, like two constants. So that's why let's express this 5 as a product of two constants. 5 is a prime number, so it's much easier for us to work with 5, because the first way, how can we express this as 1 times 5? Second way, how can we express it, is 5 times 1, and of course with the negative sign. Let's write it, but I think we're gonna reject these negative values, but let's write the full expression. So minus 5 and minus 1. Basically we can easily reject these two things, because I'm going to show you a little bit later why can we easily reject instantly these two pairs. So minus 1 and minus 5 and minus 5 and minus 1. So we use these two expressions, so this one and this one. So we have two system of equations. So the first system of equation, let's write it on the left side. This is our first one. So a plus b equal to 1, a minus b equal to 5. So a plus b equal to 1 and a minus b equal to 5. This is our first system of equations, and the second case, 5 and 1. So a symmetrical a plus b equal to 5 and a minus b equal to 1. Right now let's solve. For example, let's solve quickly. Let's solve our first system of equation. That's why we can easily add these both equations. So we have 2a b. If we add it, we can easily cancel it. So we have 2a, this is our first system of equation. We have 2a equal to 6, and from here a is equal to 3. And few thoughts about these negative pairs. So as I said before, these values need to be positive because this is our exponential function. So a need to be greater than 0, so let's write it greater than 0, and b is greater than 0 because we're talking about exponential functions. So that's why when we have this system of equations, a plus b, a minus b, when we add it, we have 2a equal to 6. So that's why when we add minus 1 plus minus 5, we have minus 6. So basically we can reject at this moment, we can reject this negative value, and to a right here we have minus 5 plus minus 1, we have the same minus 6. So when 2a equal to minus 6, a is equal to minus 3. So that's why we reject these negative values. But in this case, we're happy that we have a equal to 3 as a positive value. So that's why let's solve, for example, for b. So that's why let's solve for b from here. B is equal to a minus 5. Yeah, so we have b equal to a minus 5. A minus 5. So that's why we have a equal to 3, so 3 minus 5 equal to minus 2. And really interesting moment, because a equal to 3 is good for us and a b equal to minus 2 is not good for us, but let's write it. So I think that we will reject this pair, but let's write this pair. So we have 3 and minus 2. This is our first system of equations, and let's solve our second our second system of equations. Let's do it. So we have the same addition, 2a equal to 6. So we have 2a equal to 6. And from here we have a equal to 3, a equal to 3. But what about b from the second equation? So b equal to a minus 1. So that's why we have 3 minus 1 equal to 2. So if we're talking about this pair, we have a equal to 3 and b equal to 2. So right now so as I said before, we have 4 cases. First 2 cases we reject in the very beginning of our solution, because we have a negative pair. We are talking about exponential functions, so that's why we're interested only in the positive values. And right now we have 2 more cases, and first of all, this case is not good for us. A is good for us, but b is not good for us, because we are talking about substitution. If we write that 2 to the power k over 2 equal to minus 2, so then this equation doesn't have roots, maybe complex root, but in our case we're talking about real number roots, so that's why we reject this branch. And our last hope, we have 3 and 2, so let's go back to the beginning. So we write that, but 3 to the power k over 2, 3 to the power k over 2 equal to a, and 2 to the power k over 2 equal to b. So let's solve it. So first of all, we have 3 to the power k over 2 equal to 3 equal to a. So we have 3 to the power k over 2 is equal to a equal to 3. And of course, these both roots need to be good for both cases at the same moment. So we have 2 to the power k over 2 equal to 2. And if you look closely, we have the same equation on both parts, because right here we have 3 to the power 1 and 2 to the power 1. So we have the same equation, k over 2 equal to 1. Yeah? So we have k over 2 is equal to 1, and we have the same exactly the same case right here on the right side. So if we're talking about k is equal to 2. This is our one and only one root. Maybe there are a lot of complex roots exactly if you plug in minus 2 with I, but if you're talking about real number root, k is equal to 2 is only one root for our question. And let's check it. Let's check this root. So check 3 to the power k minus 2 to the power k is equal to 5. So if we plug in k equal to 2, so for k is equal to 2, so we have 3 to the power 2 minus 2 to the power 2 equal to 5. 9 minus 4 is equal to 5, which is absolutely correct. So our root is good, good for us. And in the end, I want to show you the second method. This method, I do not like this method, but maybe you sometimes you run out of time on your exam, so you can easily use this method. This is not good for you, but maybe sometimes you need to solve this question quickly. So that's why when you have 3 to the power k minus 2 to the power k equal to 5. Of course, there are a lot of geometrical ways how can we solve this part of question, but if we're talking about this method, so we can express this 5 as a difference of two constant. And if you look closely, the best way to express this 5 is, so we have 3 to the power k minus 2 to the power k. The best way, how can we express this, as 9 minus 4. And why 9 minus 4, not like 10 minus 5? Because 9, this is equal to 3 square. We already have this base of 3 on the left side. We already have 2, so the best way to express this is 3 square minus 2 square. And as you can see right here, absolutely symmetrical expression. So only one case when k is equal to 2 is a root to our question. So we have k equal to 2 is a solution to this question. So this is my solution. Of course, write your thoughts in the comments below. Write maybe your thoughts, your note about this question. Maybe you have your own opinion about this solution, and write your thoughts about this part, algebraic part, about geometrical part, and of course, write your question. What do you want to see on my YouTube channel? If you're talking about solution to this question, I prefer this one. Of course, write your response in the comments below. A lot of students, a lot of teachers here, so of course write what do you think about this solution. It will be really interesting to read about it in the comments below. So thank you for your time. Take care of yourself. Have a great day. See you in the next videos.